Hello, folks. So, welcome to part two of exploring and learning ML. So, the last part I basically got interrupted and just continuing now. So, I think we were looking at types of artificial intelligence, weak AI versus strong AI, and so weak AI, what's it called? Narrow AI or artificial narrow intelligence (ANI). Okay. Is AI trained to perform specific tasks? Okay. Weak AI drives most of the AI that surrounds us today. Okay. Wow. So narrow might be a more accurate descriptor for this type of AI as it is anything but weak. It's not weak. Okay. Enable some powerful applications. This is Apple Siri, wow, Amazon Alexa, IBM Watson, and autonomous vehicles. Okay. It's made up of artificial general intelligence, AGI. Ah, I've heard of this term. And artificial super intelligence, ASI. Okay. Intelligence or general AI is a theoretical form of AI where a machine would have an intelligence equal to humans. Oh, wow, wow. It would have a self-aware consciousness that has the ability to solve problems, learn, and plan for the future, also known as superintelligence, which surpass the intelligence and ability of the human brain. Wow, okay. It's still entirely theoretical with no practical examples in use today. AI researchers are exploring its development. The best examples of ASI might be from science fiction such as HAL, The Rogue, Computer Assistant in 2001. Okay, interesting. I haven't seen the movie, but or I don't know if it's a movie. Cool. So deep learning versus machine learning. So we're looking at artificial intelligence and what is this, right? Since deep learning and machine learning tend to be used interchangeably, it's worth noting the nuances between the two. As mentioned above, both deep learning and machine learning are subfields of artificial intelligence. Where did this say that? Nowhere. Machine learning, they spoke about it. Deep learning. Uh, Okay, yeah, here, as today's subfields of machine learning and deep learning, which is only mentioned in one machine. So these disciplines are comprised of AI algorithms that typically make predictions. Okay. So we have this subfields. So AI, the subfields are machine learning and deep learning. Okay. Uh-huh. So, and then we come here. So what's the difference between deep learning? So it's worth noting the differences, nuances between the two. So they are subfields of artificial intelligence, and deep learning is actually a subfield of machine learning. Okay, so deep learning is a specific kind of like machine learning. Okay, like specific thing there, the subfield. So the way in which deep learning and machine learning differ is in how each algorithm learns. Okay, deep machine learning can use labeled datasets, also known as supervised learning, to inform its algorithm, but it doesn't necessarily require a labeled dataset. Okay, so deep machine learning or deep learning can use to inform its algorithm, but it doesn't necessarily require a labeled data, is it? Can ingest unstructured data in its raw form, text, images, etc. And it can automatically determine the set of features which distinguish different categories of data from one another. This eliminates some of the human intervention required and enables the use of larger data sets. Okay. You can think of deep learning as scalable machine learning. Okay, so it's like high scale machine learning. As Lex Friedman notes in the same MIT lecture from above. Okay, looks like I might have to go through these to understand some stuff. There's a YouTube video and this helps open whatnot. One moment. Okay, so interesting. Deep learning basics, introduction, and overview. Okay, looks like I could uh, check this out. And so classical. Okay, so classical or non-deep. Okay, so anything that's not deep learning, deep machine learning. Non-deep machine learning is more dependent on human intervention to learn. Human experts determine the set of features to understand the differences between the data inputs, usually requiring more structured data to learn. Okay. So deep learning, like some machine learning, uses neural networks. In a deep learning, it refers to a neural network with more than 3 layers. Okay, it's more than 3 layers, multiple hidden layers. Okay, including the input and output layers. Okay, this is generally represented using the following diagram. So input and then outputs, we have multiple hidden layers. Okay, has been one of the most significant breakthroughs in AI in recent years because it has reduced the manual effort involved in like building AI systems. Deep learning was in part enabled by big data and cloud architectures, okay, making it possible to access huge amounts of data and processing power for training your solution. So looks like you need a lot of compute power, basically a lot of resources, compute resources. Like say, I think in computer it's all like compute network storage. So you will need some level of compute and storage and maybe even network. So and lots of data, storing and the processing. So your artificial intelligence applications. Okay, let's look at some of these. So there are numerous real-world applications of AI systems today. Here are some of the most common examples. Okay, speech recognition, automatic speech recognition. Okay, so computer speech recognition or speech to text. Okay, I mean, it makes sense. Like you convert the speech to text and then you try to understand the text, and it is a capability which uses natural language processing to translate human speech into a written format. Many mobile devices incorporate speech recognition into their systems to conduct voice search. Siri improve accessibility for texting and all that. Okay. Customer service, online chatbots are replacing human agents along the customer journey. Okay. So changing the way we think about customer engagement across websites and social media. Okay. Chatbots answer friendly, frequently asked questions about topics such as shipping or private personal advice, cross-selling products or suggesting sizes for users. Okay. Virtual agents, I'm guessing they have this Watson assistant, of course. On e-commerce sites, messaging bots using Slack and the Facebook Messenger, and tasks usually done by virtual assistants and voice assistants. Okay. And also you have online chatbots and say even things like say WhatsApp. So computer vision, but it's not AI. I think it's just basic program, at least in some WhatsApp stuff. But yeah, some of them can be pretty much more than that. Computer vision, so this AI technology enables computers to derive meaningful information from digital images, videos, and other visual inputs. Okay, so and then take the appropriate action. So I'm guessing all this face detection and all that is basically computer vision, powered by convolutional neural network (CNN). Computer vision has applications in photo tagging on social media, radiology imaging in healthcare, and self-driving cars within the automotive. Nice. Recommendation engines. Okay, so using fast consumption behavior data, AI algorithm can help to discover data trends. Okay, that can be used to develop more effective cross-selling strategies. This approach is used by online retailers to make relevant product recommendations to customers during the checkout process. Okay, so this was also bought with this and things like that, I guess. And based on some parameters and also automate or like you could buy this also along with this. We recommend buying this. So automated stock training, so designed to optimize stock portfolios. I don't know if this is like possible. I've heard some mixed opinions around this. Like AI-driven high-frequency trading platforms make thousands or even millions of trades per day without human intervention. Okay. Fraud detection, banks and other financial institutions can use machine learning to spot suspicious transactions. Supervised learning can train a model using information about known fraudulent transactions. Anomaly detection can identify transactions that look atypical and deserve further investigation. Cool. So history of artificial intelligence, key dates and names. Okay, so that's a long list. Future of AI. Cool. So what is the future of AI? While artificial intelligence remains a long way off, more and more business will adopt AI in the short term to solve specific challenges Gartner predicts. Okay. That 50% of enterprises will have platforms to operationalize AI by 2025. Okay. Um, Knowledge graphs are an emerging technology with AI. They can encapsulate associations between pieces of information and drive upsell strategies. Okay. I don't know what's that. And okay, one moment. Oh, okay. So recommendation engines, personalized medicine. Okay. So, natural language processing applications are also expected to increase in sophistication, enabling more intuitive interactions between humans and machines. Nice. Okay, so, and I guess this is like all pretty usual stuff. Something about servers and all that. Anyways, So I'm guessing we can actually go ahead and so now I have a good understanding of like AI. Okay, so it's like not the actual natural intelligence, but artificial, and you have deep learning and machine learning as subfields, and deep learning is a specific subfield of machine learning, and like it's scalable machine learning. And we have some good links to check out for later, like the YouTube thing. So after this, I wanted to check out, say, for example, this community called Hugging Face, which I've heard a lot about. So let's go quickly check that out. So Hugging Face, the AI community building the future. So this is an AI community, okay. So what can I mean, they have some services, I know that. For example, they have some community organizations and whatnot. So Pro Plan, Lab, Enterprise. So Inference API, some up to 30K into characters per month, so free community support and all that. Pro Badge, and then trade models easily using auto train with auto train, and then early access to features, pay as you go, auto train. Well, I'm guessing this is some platform to help you with some training. I don't know what that means though. More about our services, expert support, okay, private models and data sets. Oh, yeah. Create, evaluate, and deploy state-of-the-art models fine-tuned to your training data and see some of the selected task, language, upload data, and get audited into its magic. Cool. So, accelerated internship, NLP features faster using a hosted investor. Hmm. So, intrinsically, harder scale it, dedicated harder. Okay. Cool. So now, transformers and accelerated training to production. So I'm guessing, I mean, well-trained enterprise, state-of-the-art models powered by the reference open source in machine learning. Okay. So it looks like this is their biggest thing, like transformers, state-of-the-art machine learning for PyTorch, TensorFlow, and JAX. Um, don't know what this is about though. Join the Hugging Face community, augmented documentation experience, collaborate on models, datasets, and spaces. Past examples with accelerated inference, switch between documentation themes. Okay. How do I sign up? Can I use GitHub? Already have an account. No. Sign up. So, okay. Is the organization to usually find and join the company slash T1? Right. I'll probably come back to this. So I'm just gonna go ahead and like check what's out here. For so state of the art machine learning for PyTorch, TensorFlow, and JAX. I don't know what these are actually. I'm gonna have to check them out. So let me copy that out. Oops. So maybe something to check out. I'm checking out this for now. Hugging Face, and say the next thing is Transformers from Hugging Face. API is easy to easily download and train state-of-the-art pre-trained models. Okay, so you can download and train state-of-the-art pre-trained models. If it's pre-trained, where do you want it? Okay, using pre-trained models can reduce a complete cost. Okay, basically you train it already to some extent. Okay, carbon footprint and save you time from training a model from scratch. Okay, can be used across different modalities such as text classification, information extraction, question answering, summarization, translation. Okay, so let me just understand this. Classifying text. Is it kind of like what kind of text is it like, say, news, or I'm not sure what they mean. In information extraction, I can understand information retrieval in this and question answering. To know what that is. Summarization, yeah, I've seen people do summaries of a large piece of text. Translation, yeah, I can understand. Text generation, oh wow, okay. Cool. So images, image classification, object detection, segmentation, speech recognition, audio classification, and multimodal table question answering, optical character recognition, OCR. Okay. Information extraction from scanned documents. Okay, so this is similar to the Google Lens, I think. Video classification and visual question answering. Nice. A library supports seamless integration between three of the most popular deep learning libraries: PyTorch, TensorFlow, and JAX. Train your model in three lines of code in one framework, and load it for inference with another. Okay. Train your model in three lines of code in one framework. Okay. Uh, okay. So one of these frameworks use it like three lines of code and then load it for inference with another. Okay. Each transformers architecture is defined in a standalone Python module so that they can be easily customized for research and experience. Custom support. Okay. Content. This is the team. How can I accelerate support? Request record. This is the team. Interesting. Deep technical knowledge. Nice. Cool. So contents get started. Contents a quick start. Okay. So can I go to this tutorials pipelines? Load reading. Uh, hmm. Just wondering, first of all, say question answering with tasks, return an answer given a question. Okay. Two common forms of question answering. Extractor, extract the answer from the given text. Okay. Whatever text you've already given. Abstract, generate an answer from the context that correctly answers the question. How to fine tune distal BERT on the squad dataset for extractive answer, question answering. Okay. Interesting. Datasets, squad. Wondering what this is all about. Go to dataset. Use dataset in library. Papers with code. What does that mean? Oh, okay. So this one is Stanford question answering data set. Is a collection of question answer pairs derived from Wikipedia articles. In Squad, the correct answers of questions can be any sequence of tokens in the given text. Because the questions and answers are produced by humans through crowdsourcing, it is more diverse than some other question answering datasets. Okay. One and contains, oh wow, that's a lot of 107K question answer pairs and 536 articles. Open domain squad open, the notice version combines 100,000 questions. Written, okay. With over 50,000 unanswerable questions written adversely by crowd workers. Found that are similar to the answerable ones. Okay. So benchmarks, best model. Okay. There are some codes over here for different things. Dense retrieval, dense passage retrieval for open domain. Exploring the limits of transfer learning. Okay. Interesting. So, I'm wondering what is this papers with code thing, the browse state of the art. Can I try to understand what this is about? It's to create free and open source, open resource with machine learning papers, code, data sets, methods. Nice. Interesting. So I'm guessing this is a pretty important thing to check out, papers with code. I'll probably put this in my list of ML, awesome ML maybe, and then say papers with code or here, go back and then get this in. And data sets, methods, and all that will be just part of this. Hugging is okay. Cool. So subset, plain text, split, train, validation. Okay. So validate the answer. Okay, this is the train. Okay. As inversions, dummy, community. Okay. This is pretty nice. This is like a Git thing. It's similar to Git. Seems like it is a Git thing. Commit and all this. Git commit this branches and also similar to a GitHub UI. They have a UI here. So data sets. So interesting. Most downloads. So you have the most downloads in what? I don't know. Wait, let me see. It's on red underscore caps. I don't know what that is. So it's a large data set of 12 million image text pairs collected from Reddit. Ah, red caps. Is it captions from Reddit depict and display a wide variety of objects and scenes? Okay. The data is collected from a manually curated set of subreddits 350 total. Coarse image labels and allow steering on the data set composition without labeling individual instances. It's created by the people for the people. It contains everyday things that users like to share on social. For example, hobbies and pets. Captions often contain specific and fine-grained descriptions. Northern Cardinal, Tajman. Okay, interesting. So, okay, so this is about images and text pairs, and you can use it to train things and then, I guess, find out more. Train and auto train, papers with code, edit. Not sure if papers with code is a Hugging Face thing. It might be. Let's check it out. Hello. Okay. From Meta. It's from Facebook. Okay, it's from Meta. Previously it was Facebook. So team, the core papers of this, there's a service has been created and is managed by Robert. Okay. Cool. No data shared with any Meta platform spawned on release.com. Cool. Interesting. So use the data set library. Uh-huh. Edit data set card. Okay. Okay, so you have all the data sets here. Interesting. They loaded from here to there. Okay. So considerations related table of description. Cool. Repository. Okay. Downloader. Download extending the response. Oh, this can see this download. Interesting. Redcast dataset. Red cap. Okay, so redcast dataset.github.io. Okay. Can I go to this website? Oh, .xyz. Okay. I say this. Will it go to? Okay, it will go to this. So R16 birthday gift from father. Okay. Handmade horn handle. Okay. Hair root. My dreamer of dreams. My progress on Fox Autumn Sampler. Design and Natalia. Okay. Dancing in abandoned Soviet sports complex. Uh-huh. Airplanes. Interesting. So I'm wondering how people like just use this data and like do stuff. It's interesting. Anyway, so I was looking at question and answering and like um I got into the squad data set and like started going into other data sets. But I think it's going to be interesting to find out about different. I'm getting excited like a little kid looking at a lot of candies in a candy store. Um, I'm gonna have to actually start somewhere. So I'm guessing I'll probably start say over here or one of these, so that I can understand what I'm trying to do. But one of the interesting things that I liked was say genetic algorithms and then also neural networks wherein the machine played a game and it was trying to win the game and it learned to play the game on its own without any like input apart from saying that did it win or lose, did it score points or not. So that was pretty cool. So yeah, I am looking forward to learning more of machine learning and more like trying it out first before I learn the math or the whole internals behind it. So looks like I have a lot of reading to do, and I'll probably do that and then get back. So that's all I had in this video. I'll see you in the next one. Bye bye.